All right, so let's take a look at this first problem. So we know that we have one side that's equal to x, we have another side equal to 2x minus 4, and we know that the three sides together have to equal 25. So we can say that the third side has to be equal to 25 minus the first side minus the second side. When we simplify this, we're going to end up with 29 minus 3x. Okay, we also know that any two sides added together have to be greater in size than the third side. So we can say that x plus 2x minus 4 has to be greater than 29 minus 3x. We can also say that x plus 29 minus 3x has to be greater than 2x minus 4. Finally, we can say that 2x minus 4 plus 29 minus 3x has to be greater than x. All right, so up here when we simplify, we're going to end up with 3x minus 4 is greater than 29 minus 3x. And when we simplify again, we can say that 6x is greater than 33, which is to say that x is greater than 5.5. So what we did was we added 3x to both sides here, and we added 4 to both sides to end up with 6x greater than 33, and then we divided both sides by 6 to get x is greater than 5.5. Okay, now for this one, we're going to end up with, over here, 29 minus 2x is greater than 2x minus 4. And that's going to lead us to, when we get all this worked out, we're going to get 33 is greater than 4x, which is to say that x is less than 33 divided by 4, 8.25. Finally here, the last one, we're going to get, on this side, when we simplify, we're going to get 2x minus 3x is negative x. Negative 4 plus 29 is plus 25 is greater than x. And we'll add x to both sides to get 25 is greater than 2x. Or 12.5 is greater than x. Or in other words, x is less than 12.5. But we already know that x has to be less than 8.25. So here's what we have. The most restrictive conditions. We have 5.5 is less than x is less than 8.25. And so when we said that this has to be, if x has to be an integer, we can say that the only integer values that satisfy this are x is equal to 6 or 7 or 8. Those are the integers that are between 5.5 and 8.25. All right, so let's take a look now at our next problem here. Okay, we're told that the measures of the angles in degrees are 3x minus y, 2x plus y, 2y minus x. So since this is in a triangle, we know that the angles have to sum to 180. So we can say that 3x minus y plus 2x plus y plus 2y minus x has to equal 180. So we have 3x plus 2x minus x is going to give us 4x. We have negative y, positive 2y is going to give us positive 2y is equal to 180. Or, dividing both sides by 2, 2x plus y is equal to 90. And we could rewrite that as y is equal to 90 minus 2x. Okay, the other thing that we know is that each of these angle measures have to be greater than 0. So we can say that 3x minus y is greater than 0. We can say that 2y minus x is greater than 0, and 2x plus y is greater than 0. Well, what we can do is we can replace y in these equations with 90 minus 2x. So we get 3x minus 90 minus 2x is greater than 0. We get 2y, no, actually, we should replace that y. So we're going to replace that y. And we're going to say that 2 times 90 minus 2x minus x is greater than 0. Finally, we're going to say that 2x plus 90 minus 2x is greater than 0. Okay, so the first one here we simplify and we get 3x minus 90 minus 2x is going to give us 5x minus 90 is greater than 0, and we can say that 5x is greater than 90. We add 90 to both sides, divide both sides by 5, we get x is greater than 18. Over here, we're going to get 180 minus 4x minus x is greater than 0, which is to say that 180 minus 5x is greater than 0. And we can simplify to 180 is greater than 5x. And that means that when we divide both sides by 5, 36 is greater than x. Or in other words, x is less than 36. Finally, for the third one here, the 2x and the negative 2x cancel out. We get 90 is greater than 0. Well, that's always true. So what we can say in conclusion is that 18 is less than x is less than 36. So any values between 18 and 36 are going to satisfy this equation. One of the things you'll notice is that we found that 2x plus y is equal to 90. And we also saw that one of the angles in our triangle is 2x plus y, which means that that angle is always going to have a measure of 90 degrees. Okay, so let's continue. Let's continue on to problem number 3. Okay, a triangle has a side length of 23 minus 2x, 3x, and 4x minus 2. The range of possible values for x. What do we know? We know that 23 minus 2x has to be actually less than, I can erase that, and say 23 minus 2x has to be less than 3x plus 4x minus 2. So 3x is one of the two sides and 4x minus 2 is the other. So any one side has to be less than the sum of the other two sides. So this one's going to give us that 23 minus 2x is less than 7x minus 2. And when we rearrange everything, we're going to get 25 is less than 9x. Or in other words, 25 over 9 is less than x. Okay, so x has to be greater than 25 over 9, which is a little bit less than 2. All right, we also know that 3x, let's isolate this, 3x has to be less than 23 minus 2x plus 4x. And we can simplify that to say that 3x has to be less than, we'll combine these two to say that 23 plus 2x, and we'll subtract 2x from both sides to say that x has to be less than 23. Okay. Our third condition is that 4x minus 2 has to be less than 23 minus 2x plus 3x. Again, the sum of two sides has to be greater than the third side. That gives us 4x minus 2 has to be less than, when we combine over here, 23 plus x. And when we're going to subtract x from both sides, add 2 to both sides, we're going to get that 3x has to be less than 25, which is to say that x has to be less than 25 over 3. So now we have our conditions. We can say that x has to be less than 25 over 3, greater than 25 over 9. 25 over 9 is a little less than 2. 25 over 3 is a little more than 8. So now we have our range of values that would make this a possible triangle. Okay, so now we're being asked, what are the values of x that would make this an isosceles triangle? All right, so that means that what we have to do is we have to set each of the two sides equal to the third. So, or set any one side equal to another side. So the three possibilities are as follows. We can say that 23 minus 2x, which is one side, is equal to 3x. We can say that 23 minus 2x is equal to 4x minus 2, or we can say that 3x is equal to 4x minus 2. All right, when we look at this first one here, we can say that's going to become 23 is equal to 5x, which is to say that 4.6 is equal to x. Over here, we're going to get that 23 plus 2, or 25, is equal to, we'll add 2x to both sides to get 6x. So 25 over 6 is equal to x is equal to 4 and 4 and 1/6, or 4.17 more or less. Over here, for the third one, we're going to get 3x is equal to 4x minus 2. So we can say that 3x plus 2 is equal to 4x, or 2 is equal to x. Okay, so we have three possibilities. We have x is equal to 2, we have x is equal to 4.17, x is equal to 4.6. When we go up to our previous problem and see the conditions that x has to be between 25/9 and 25/3, or in other words, between about 2.78 and 8.33, only one of our solutions here for B meets those conditions, actually two of them. And we could say that x could be 4.6, x could be 4.17, but x cannot be equal to 2 because that does not meet our condition up here from problem 3a. Okay, so let's keep going here. All right, problem 4. 3x squared minus 4x is equal to 5. Well, that can become 3x squared minus 4x minus 5 is equal to 0. Now we can use the quadratic equation. And we have that a is equal to 3, b is equal to -4, and c is equal to -5. So the quadratic equation says that x is going to be equal to negative b, so we'll have -4 plus or minus the square root of b squared, so we'll have -4 squared, minus 4 times a, which is 3, times c, which is -5. And all of this is over 2 times a, or 2 times 3. Okay, so when we simplify, we're going to get x is equal to 4 plus or minus the square root of 16 minus 4 times 3 times -4 times 3 times -5. So we have 4 times 3 is 12 times -5 is going to give us positive 60. So we're going to end up with plus 60. And all of that is over 2 times 3, or 6. So we're going to end up with x is equal to 4 plus or minus the square root of 76 over 6. And it turns out that we can factor a 4 out of 76, so we're going to get that x is equal to 4 plus or minus 2 times the square root of 19 over 6, or simplifying by dividing everything by 2, we're going to get x is equal to 2 plus or minus the square root of 19 over 3. Okay, problem B. Find the maximum value for f of x if f of x is equal to negative 4.9x squared plus 40x plus 240. Well, one of the things we know from the quadratic formula is that the x value of the vertex is going to be equal to negative b over 2a, which is going to give us negative 40 over 2 times negative 4.9, which is equal to negative 40 over negative 9.8, or 40 over 9.8. When we divide 40 by 9.8, so 40 over 9.8 gives us a value of approximately 4.08, which is the value of x that will give us a maximum y value in f of x. So what we can do is now we can substitute in this value, 4.08, in for x. And when we do that, we get negative 4.9 times 4.08 squared plus 40 times 4.08 plus 240. And that's going to give us, and I did it in a more exact way elsewhere, it's going to give us 321.63. So that's the y value, that's the maximum y value for this function here, which is a parabola, and it opens downward, so it's going to have a maximum value, and that's going to occur when x is equal to about 4.08, and then the y value there will be about 321.63. Okay. All right, so let's continue on. So we just did problem number 4, so let's go on to problem number 5. Okay, find the exact values of x and y in each of the following. And in the first one here, we're using the substitution method by expressing y in terms of x or x in terms of y, and then substituting in the other equation. All right, so let's do this. Let's say that we'll take this equation here, and we'll say that 2x is equal to negative 3y plus 6. And we'll say that x, therefore, is equal to negative 1.5y plus 3. We'll go back to our other equation, 5x minus 2y, and we will substitute for x. We'll say that 5x, but we'll replace x now with negative 1.5y plus 3 minus 2y is equal to 10. That's going to give us negative 7.5y plus 15 minus 2y is equal to 10. So we will now combine the negative 7.5y and the negative 2y to get negative 9.5y is equal to, and we'll subtract 15 from both sides to get negative 5. And when we divide both sides by negative 9.5, we'll get that y is equal to negative 5 over negative 9.5. And we could say that's equal to negative 10 over negative 19, or just 10 over 19. And I got the 10 over 19 by multiplying top and bottom here by 2 to get from negative 5 to negative 10, negative 9.5 to negative 19. Okay, so now we have our value for y, and now we can just substitute that back in to say that x is equal to negative 1.5 times our y value, 10 over 19, plus 3. So x is equal to negative 1.5 times 10/19 is going to give us negative 15 over 19. We multiplied the negative 1.5 times 10 to give us negative 15 over 19. And plus 3, well, we want to have a common denominator, so 3 we can also express as 57 over 19, because 57 over 19 is 3. So now we can say that x is equal to negative 15 over 19 plus 57 over 19 is equal to a positive 42 over 19. So that gives us our x value and our y value. And we can check and say that, let's look at 2x plus 3y. So we have 2x is 2 times 42 over 19, which would be 84 over 19, plus 3y would be 30 over 19, would give us 114 over 19, which is equal to 6. And you can check that math if you would like. Okay, so that's the substitution method, but we also have what's called the elimination method. And here, and you may find this easier, we say we want to take these two equations and we want to multiply one or both equations by whatever it is we need to do in order to be able to eliminate one of the variables. So in this case, since we have a negative 3y and a positive 5y, we know that if we multiply the top equation by 5, so we have 5 times 5x minus 3y is equal to 12. And the second equation by 3, so 3 times 2x plus 5y. Oops, don't want to do that. Is equal to 10. So what we end up with here, up top, we end up with 25x minus 15y is equal to 60. The second equation, we end up with 6x plus 15y is equal to 30. So when we now add this equation and this equation, we're going to end up with 31x is equal to, these y's cancel out, and that's exactly what we wanted. We wanted to be able to have our equation in terms of one variable only. So we're going to end up with 25x plus 6x, or 31x, is equal to 60 plus 30 is equal to 90. So x, therefore, is equal to 90 over 31. So now we can plug that back in and say that, for example, 2 times 90 over 31 plus 5y is equal to 10. And we're going to re-express 10 as 310 over 31. So here's what we have now. 180 over 31 plus 5y is equal to 310 over 31. Well, when we're adding 180 over 31 plus something to get 310 over 31, we know that 5y therefore has to equal 130 over 31, because we need to add 130 to 180 to get 310. So 5y is equal to 130 over 31, which means that y itself is equal to 26 over 31. So now we have our two values, 90 over 31 for x, 26 over 31 for y. Okay, number 6. Let's not worry about number 6. Okay. But let's look at number 7. Or actually, let's look at number 8. Okay, so two strings each measure 100 centimeters in length. The first is formed into a circle, the second into a square. Find the ratio of the area of the square to the area of the circle. Okay, so let's think about this. So we have a string, and it's 100 centimeters, and it's been formed into a circle, and in the other case, it's been formed into a square. So we know in the square, each side is going to be 25. And that means the area of this is going to be 25 squared equals 625 centimeters squared. The circle, on the other hand, we know that 100 is equal to the circumference of the circle, or 2 pi times r. That's the formula for the circumference. So that means that 100 over 2 pi is going to be equal to r. The area of the circle is equal to pi r squared. So we can say the area is equal to pi times our expression for r, which is 100 over 2 pi, and that is squared. So we're going to get it's equal to pi, or pi over 1 if we want to re-represent it that way, times 100 over 2 pi squared, or 10,000, over 4 pi squared. Well, the pi here and the pi squared here are going to allow us to simplify, and we're going to end up with just 10,000 over 4 pi. And we can cancel out here to get 2,500 over pi as the area of the circle. And that'll be in centimeters squared, and you need to compare that then to the area of the square formed with that same 100-meter long string. Let's take 5